So welcome back, and we're going to be talking about function notation in our lesson here. As a preamble, don't be so alarmed about function notation. It's actually not that hard. However, it is also a key component in this whole course, which eventually we will evolve to understand what it looks like. So one more time, in grade 9, you learned about this equation. Notice I gave it an example, y equals mx plus b, y equals 2x plus 1. The graph looks like something like this. 1. And this is in grade 9 and grade 10, right? How do we remember it? So what is function notation? Watch carefully what I'm going to do to illustrate from this example of the equation. That's all I wrote. Noticing some of you saying, well, what did you do? You just wrote an f bracket x bracket. So this is called function notation. And the way that you say this, f bracket x bracket, you say this as f of x or f at x. So in grade 9, you would say something like this. Solve for y when x is 3. That's what you would write in English, right? But in grade 11, this function notation illustrates the concept of inputs and outputs, or more importantly, in grade 11, you would write it this way. Notice, it's so much faster, so much easier. This x is the input of 3 into the expression, 2x plus 1. So notice this is really straightforward. In grade 9, this is what you would write in English, and you would solve it. So in grade 11, what would you do? I think a lot of you understand. We're going to replace the x with that 3, because it is the input, and find its output. A lot of you are also realizing f at x is analogous to y. So if you were to write this as an ordered pair, x comma f at x. That's really what it is. It is really what y is. It is really the dependent variable. A lot of us can do this math really easy. 2 times 3 plus 1, we always use order of operations. 7. Graphically, a lot of you understand what that means. If I said, what's the input of 3? I apologize, my scale is not the best. 7 is what you would read over here. Right? So f at x is really the y components. It's that easy. I'm just trying to connect the graph, an equation, and inputs and outputs. Let's take a look at the first example 3. Let's just see if I'm still there. Let's just read what's underneath. We'll skip the first one, if that's okay. We'll do example 2. So it says f at -1. That's how you would say this to somebody. And the function you see in example 3, I'll just write it above if people are following at home, or maybe below the ground. F at x is equal to 3x squared minus x minus 6. Can I get a volunteer to tell me what would I do to solve for this? And I'm using example 2. What do you think we would do? Any volunteer? Jen?
First you would do 3 times 1 squared by 2.
Hold on. Let's do a substitution first. Is that okay?
Okay. And then minus -1 minus 6.
Let's just pause there. Everyone okay? It's actually important. I don't recommend doing the mental math, ladies and gentlemen, at home. Just do the substitution, and notice where I'm putting the parentheses or the brackets. So typically this is like now a grade 9 question, but as you can tell, some students make the error when they start processing too quickly. Can I get a different volunteer to give us the next step? Because Jasmine started us off nicely, but in replacing all the x's with -1, because that's what we're trying to find. Again, in English, you would say, please evaluate for this question when x is -1. What is y? That's all it's asking you to do. Any volunteer? You don't have to give me the answer. You can just give me an intermediate step. What would this evaluation be? 3 times -1 all squared. Emma?
You have to square the -1, which is 1, and then 3 times 1 is 3.
Thank you. And how about this part?
And then because there are two negatives, it's gonna become positive, so +1.
Thank you very much, Emma. Plus
And
minus
then
correct.
-6.
-6. That's why I want you to be very, very careful what it means to input. Thank you so much. Some of you are definitely stronger than, to be honest, grade 9s or 10s, because they forget about negative, double negative. You explained it perfectly, nicely done. And I think everyone understands the answer is 3 plus 1 is 4, 4 minus 6, -2. -2. Any question about this? Pretty straightforward, pretty easy. So I'm going to skip example 3 for that part. Let's just do orally example 4 online. Here we go. Notice we gave you this kind of looking weird function. It is a function, right? You did a vertical line test. It solved it there. Any volunteer for example 4? Notice you're reading on that graph. What is f of 5? Really easy. There is an answer for this. Aruna? 3. It is 3. Nicely done. So the answer for example 4 for part 1, it is 3. How about for example, question 2? Different volunteer. F at 0. Jasmine?
2.
It is 2. And last but not least, what? 1. It is 1. Notice, ladies and gentlemen at home, the answers for questions 1, 2, and 3 are 5, 2, and 1. Not, I said 3, 2, and 1. I can't read properly. Any questions about that before we move on to example 5? So example 5, let's do it on the chalkboard. Well, let's do 2 examples. I think you guys are going to grasp this really quickly, and it is, I think, on the PowerPoint. Example 5, let's do question D. Now, I haven't really given you an understanding of what these represent, the notation. You're just getting used to the algebra. Okay, so there is some key things here. Can I get a volunteer in the class to actually say this to somebody? How would you say this to somebody? Say this. Think about it for a second. I know it's weird, but how would you say that? Jasmine, want to try?
I think it's function of x minus 2.
Close. It's okay. It's not the best way. And I erased it. That's why. Christina?
F of x minus 2.
F at x minus 2. F at or f of, right? I mean, you're correct. It is a function of x minus 2. So what we're trying to share with you, ladies and gentlemen, we're not always inputting numbers. Right? We can actually input other symbols, or we can input expressions. And in this example, I think a lot of you know what we're going to do. Ted, do you have an idea what we're going to do next for this one?
Just sub it in.
Yeah, sub it in. So how would I sub it in? What would I write here?
Me?
Yeah, Ted. Sorry, it's okay. Because I just want class participants. Is that okay, Ted? Yeah.
It's 2x minus 7 minus 2.
2x minus, well, that's the minus 7 there. So 2x minus 2, right? Because we have to input there, right?
Oh, for that one, no, yeah.
Yeah, is that okay?
Yeah.
So that's what we're going to do before we continue on, right? Different volunteer finish it off? Now it becomes an easy math question. Jasmine?
2x minus 4 minus 7 and 2x minus 11.
That is the answer. Nicely done. So there's a point of why you're practicing this, and we'll talk about it more in detail. The last one we're going to do is question F. And again, hopefully it's going to be there. This is actually kind of funny. This question here is what's called a composite. It's the best analogy I can give you is it's a function within a function. It's like for some of you that play video games, you can't pass this point until because there's a magical wall, or like a Snorlax is blocking your pathway or whatever. You actually have to finish a mini quest first before you actually can do it. And so that's why a lot of games and coding actually works well. So this is called a composite. If you really want to know, some students know this as this, but I'm going to erase that. So we're going to look into this. And so what it tells us to do for this question F, and I'll do this one, we have to input versus g at x. Well, what's g at x? G at x is x squared plus x. So do that first, because that's what that translates to. And then, just like how Ted helped us out, 2 times x squared plus x minus 7. Before we continue, everyone okay? So then you start evaluating this, distribute property that. You get 2x squared plus 2x minus 7, and unfortunately that's where we're going to stop. So a lot of you realize when we evaluate these function notation questions, we tend to have them in what's called standard form. Okay? I think that's it for function notation.